Hey everybody! Hey! Hey everybody! Hey! Welcome to Comics Curing Cancer! Woo! And now your host, Matthew Murtha!
Hello! Yeah! Welcome! You guys ready to talk science? Oh, you researchers. Once again, welcome to Comics Curing Cancer. This is a science talk show where we hope to bridge the knowledge gap between researchers like yourself and the general lay public. We hope to do so using comedy and conversation. Yeah? It's good stuff. So tonight we have a very special episode. We'll be talking about neutron stars and binary star systems with Iago Herrera. It's a great episode, but before we get started, a few announcements, as we normally do. Once again, I just want to remind everybody that this show is it's a live recording in front of a beautiful studio audience, but it's recorded for radio and podcast to be broadcast the world over. Now, we have clearly millions of listeners throughout the world, yeah? And then for our listeners at home, I just want to point out that this is obviously a model convention this week because we are live with an audience of at least 4,500 people, I think. Each and every one of them drop dead gorgeous. I'm in love. I just want to point out that if you guys go ahead, like our Facebook page. If you ever come across an interesting or funny science article or something that just butchers the science, go ahead, post it on our page, and we'll be sure to make fun of it in the following weeks. Also, it's a way to get the news out, let people know, and then you can interact with us as well. We're also going to start a newsletter each week. So if you find there's an email or a little pad of paper in the back there, you can write your email address down. And we'll email you once a week a newsletter. So our DJ Charms here, each week he comes up with actually a very special and curated set list of music, all with consistent with the show's theme. And so what we'll do with the newsletter is we'll explain in more detail the next week's guest. We'll have the list of music if you want to have science-themed tunes for your next party. Guaranteed to kill, I promise. And some other interesting and fun links like that. So without further ado, I'd like to introduce our co-host for the evening, Miss Hannah Becker. Welcome, Hannah.
Hey, what's up?
How are you feeling tonight?
I'm feeling good. Feeling great. It was my birthday on Saturday. I don't know if anyone knows that.
Woo!
Woo! So I just ride it out for the whole month, you know. My birthday month, you know.
It's your birthday month. Hannah, did you see that I was in the news recently?
No, I didn't. What do you mean?
Yeah, so apparently I'm a big deal down in the Caribbean. I don't know if you guys know this. The Haitian press
What's
have
a
caused me...
wet T-shirt contest or something?
That was last year. But apparently I will be making some people wet this weekend. No, the Haitian press called me a force of nature. Strong winds. Hawaii.
Oh, no. What happened? What did you do, Matt? What did you do?
Well, they've taken to calling me Hurricane Matthew.
Oh.
That's right. So our staff meteorologist, Mr. Luis Vendrell. No,
wow.
He's Catalan. I can't pronounce it correctly. Luis Vendrell?
Luis Vendrell.
Vendrell. He said that I was, in fact, the sexiest storm system.
He did
True?
say that.
No? Let's move on to headlines.
Headlines! Ooh, I like this.
All right, so this is the part of the show where we talk about the latest and greatest in science news. Starting off tonight, we have a recent article in the magazine Atlantic that was describing a unique homespun experiment that was testing the ability for centripetal force to help people pass kidney stones. A researcher at the University of Michigan decided to make a model kidney and take it on roller coasters to see if it would help kidney stones pass to the urinary tract. True story. Science is amazing. So he made this model, and then he went on the roller coaster many times, and he found actually there was an enormous, not only did it help pass kidney stones, but there was an enormous difference between when you sit in the front of the car or the rear of the car, yeah? So stones passed to the urinary tract at an astounding 63.89% of the time when you were sitting in the rear of the car, compared to just 17% when you're in the front. And this is based only on 60 rides on a single roller coaster.
Okay, Matt. This sounds like research performed by an 8-year-old kid, right? Oh, I had to ride the roller coaster 60 times just to be totally sure. Right?
Come on. An 8-year-old? Would an 8-year-old make a 3D model of a kidney and fill it with his own urine?
I mean, he was quoted as saying, quote, "I spent my life playing in pee," end quote.
Well, I mean,
he just only recently got interested in kidney functioning, Matt.
That's disgusting. Though I have to say, in hindsight, if you read the actual research article, the words awesome, totally cool, and wowzers appear way more frequently than you would ever expect in an academic article.
That's what I'm saying as a child. Anyway, Disney executives and California legislators were salivating at the news. Okay, come on, California. Medical marijuana cards aren't enough for you. Now you're going to give out medical season passes to Disneyland? Not fair.
I'm going to sign up to be number 1 on that list.
For the medical marijuana or for the rides, Matt?
For science. For science. Thunder Mountain? It's classic. All right. No, the thing I found funny, though, is that he literally did use his own pee in this model when he went on the ride. And he did it because he was trying to avoid criticism. And this kills me because only a fucking scientist would think that using water, rather than pee, would invite criticism. He was afraid that the other scientists would be like, no. You can't use water. It's a confounding factor. Only a fucking scientist would think that using real pee will keep you from being made fun of. Right?
Yeah, still make fun of him.
Yeah. Moving on. This is exciting. So Laura Sampson, a postdoctoral researcher at the Center for Interdisciplinary Exploration and Research Astrophysics.
He couldn't say it earlier today.
Well, it has the sexy acronym of Sierra.
Ooh.
Anyway, so she's a postdoc at Northwestern University, and she just won a $60,000 fellowship. It's from L'Oreal. It's part of their Women in Science program, and this is meant to further her research in black holes and gravitational waves.
It's because she's worth it.
I don't get that joke. Personally, I think this is horrible. This is terrible news. Look, clearly this is just fueling the disgusting stereotype, which I do not share, but it fuels the disgusting stereotype that women need $60,000 of makeup if they're going to be a scientist.
Oh, Matt. Well, L'Oreal later rescinded the offer when they discovered that gravitational waves had nothing to do with achieving this season's perfectly on-trend tussled waves.
Look, she can do it without a $60,000 grant.
Yeah,
well done. Personally, though, are we sure that it was L'Oreal that funded it? Maybe it was Maybelline.
I made him do it.
Not a lot of cosmetic fans in the crowd, huh?
No.
Science. A group of researchers at the University of Manchester discovered that the avian pigment for red coloring, it's a pigment called pheomelanin. So they found that this pigment was actually within fossilized remains of dinosaurs. And so naturally, they decided that this meant that the dinosaurs had red hair.
With this news, scientists also confirmed that dinosaurs had no souls and probably went extinct due to prolonged sun exposure.
I have to say, the idea of 1 million ginger dinosaurs, it makes mass extinction make way more sense. Now, so to be fair, though, this is another case of terrible science journalism, because if you read the research article, they actually found a number of pigments in these remains, yeah, and the pheomelanin, the one for red, wasn't even the most abundant. Other pigments that encode for darker hairs, brown and black, were more prevalent. But of course, the headline reads, ginger dinosaurs. Now, I think this is, again, like, just kind of crappy reporting, right? It's as if finding Mein Kampf on your grandfather's bookcase and then calling him a Nazi.
You know what, Matt? As a Jew, I'm really offended that you're equating redheads and Nazis. At least the Nazis were organized. Sorry, at least the Nazis were organized. I'm Jewish. I can say it. Don't worry, guys. You can laugh at the jokes. It's okay.
We really hate red people. Redheaded people.
Redheaded people.
We're going to blame these jokes on Christopher Drifter tonight.
They're redheaded Jews, too. It's fine.
The least loved. Sorry. All right, we'll move on.
A lot of Jew lovers in this audience. I'm really happy.
Jeez. Anyway, we need to move on. Oh, this is my favorite. All right. So big news in fertilization technology, yeah? Thanks to I love that you're ready for this. Yeah. Thanks to an international cooperative effort, the first baby was born to 3 genetic parents using a technique called spindle nuclear transfer.
This technique in France is called ménage à trois.
Yeah, I've never heard of that. So this 3-parent technique, of course, should not be confused with the excellent 1980s movie called 3 Men and a Baby.
I don't know what you're talking about.
3 Men and a Baby? Starring
No
Tom
idea.
Selleck? Tom Selleck. The
know.
Tom Selleck. People Magazine, 1987, most sexy man alive.
I wasn't even alive then, Matt.
Tom Selleck, the inspiration for this beautiful mustache.
I noticed you did something different there.
It's sexy, right?
Um,
Maybe you've heard of his other movies, like the 1990 fantastic flick called Quigley Down Under.
doesn't ring a bell. I don't know.
How about the 1989 movie, Her Alibi?
Do you guys know any of these movies?
Hannah. TV movie, Jesse Stone, Stone Cold.
Nope.
The sequel, Jesse Stone, Night Passions.
Not that either.
There's a country with an entire day dedicated to Tom Selleck.
What fucking country would that be?
Tom Slovakia. All right, maybe you know the third sequel in that wonderful Jesse Stone trilogy, or actually series. It's called Jesse Stone Death in Paradise.
No. Was
Jesse Stone Sea Change?
No.
Jesse Stone Thin Ice.
Was he Jesse Stone? I thought Jesse Stone's a woman. I don't know.
There's like a million of these. Jesse Stone Lost in Paradise. Jesse Stone Benefit of Doubt.
Nope.
Tom Selleck used to be a salesman. Do you know what his boss said every time he made a sale?
What?
Tom Selleck again.
Oh, God, Matt.
Little known fact, and this is probably says more about me than Tom Selleck, but he was actually cast to be the original Indiana Jones.
Interesting.
You guys are not impressed? Look, this is a beautiful man, and he's got a beautiful mustache.
No, Matt, come on. This is like a science show.
All
This
right.
is not a Tom Selleck
No,
show.
you have to know who Tom Selleck is, though. He's central to my life and possibly my father. He was Monica's boyfriend in Friends.
Oh, of course. Yeah, okay. Yeah.
See?
It's fine, I guess.
Handsome devil. All right, let's move along. Researchers from California are attempting to grow a human pancreas inside a pig. This is true. So what they did is they injected human stem cells into a pig embryo, and they created this man-pig thing that is known as a chimera.
Is chimera just a fancy name for man pigs?
Possibly, or men's right activist. All right.
Feminism.
I think we insulted
Boom.
somebody. Don't date that guy. Anyway, Creedy. All right. In order to do this, they had to use a couple of techniques. So they first started with a pig embryo, and then they used CRISPR, the latest and greatest gene editing technology. Yeah? Come on, show your bona fides. All right, so they used CRISPR to knock out the genes that are responsible for developing a pancreas. So this pig embryo will grow, but will grow without the pancreas. And then by injecting the human cells, the idea is that the human cells will actually fill this genetic niche or void and then create a totally human pancreas with inside the little pig baby.
Naturally, treating pigs like easy bake ovens comes with ethical concerns. Researchers' main concern is that cells may contribute to the pig's brain, making it more human.
I think this is a sign of just how miserable researchers' lives are. If they do not want even a pig to have like a semblance of their life.
Yeah, actually, organizations campaigning for the end to factory farming are dismayed at the thought of organ farms. Animal rights activist Peter Stevenson from Compassion in World Farming is quoted saying, quote, "I'm nervous about opening up a new source of animal suffering." There.
We're going to fire these writers, yeah?
God, terrible.
They're off the list. Of course, Trump supporters are worried that pigs might... There are men's rights activists in here. Trump supporters are worried that pigs will become more intelligent and more intelligent than them.
Yeah, but researchers involved in this study argue that the pigs already are.
I, of course, would argue that Trump shows you what happens when you put a pig's brain inside a man's body.
Amen. Amen.
All right. This next one is great. You'll love it.
Especially the men's rights activists.
Yes.
You're going to love this one.
5 wild lady lions. Say that 5 times fast.
5 wild lady lions, 5 wild lady lions.
Don't brag. 5 wild lady lions in the Moriami Game Reserve in Botswana have started growing these big, beautiful manes. And they've started to adapt other features of male behavior as well. So according to recent observations published in the African Journal of Ecology, at least one of these maned lionesses has been roaring frequently and even been shown to be mating with other females. It gets worse. She's even killed 2 cubs. Yeah, a behavior only found in men.
You know
Male lions.
This is badass, though. Come on, right? Because who said, what society said that only male lions can roar, right? What society says that only male lions can mount other lions, right? What kind of society says that only male lions can kill their cubs? Down with the lion patriarchy. Boom. Woo. Fuck the patriarchy. The lion patriarchy. And the human one. All of it.
Of course, I have to note that while... sorry. While this lioness appeared to be a male in both behavior and appearance, clearly she was lying.
Terrible.
I'm sorry. All right, so some research argue though that this is an adaptive strategy because lady lions wearing a mane, they find that they can actually get out of parenting responsibilities such as hunting, feeding, and cub rearing.
I think what this does is place anti-gay activists in a very, very strange position. Because now they can't say that defying gender norms is unnatural or a choice, and now they have to make the most common and least effective argument, which is, like, because I want to and I'm afraid, because my dad won't love me, or because I'm a terrible person, you know?
No, these are the anti-gay activists, don't worry.
Yeah, yeah.
Like that guy. Just assuming. Sorry.
Really getting the crowd on our side here.
I'm a natural with people. No, the idea though of these like transgendered, gender-bending lionesses, personally I think this gives a whole new meaning to the term gay pride.
But you get it, guys? You get it? Like
I'll laugh a minute here.
A pride of lions, you get it?
Gay pride.
Do you get it? Anyway, that's
it
Tommy
for
News and
headlines.
Science. Woo!
Thank you.
This is like so sexy.
DJ Charms.
Boom, killing it.
Yeah, give him a round of applause.
Yeah.
So now the moment you've all been waiting for. It's my esteemed pleasure to bring on Yago Herrera.
Herrera.
He's from Argentina. He's now a PhD candidate at UPC.
Yeah.
Ladies and gentlemen.
Look at these luscious locks. We need to get like a fan in here. Like,
Woo. It just got hot in here. Take your time. We're going to drink it in.
people are loving this. I'm so sorry for our radio listeners that can't see this right now.
Yeah, I'm sorry that we're not broadcasting on Facebook tonight with the video, and we're depriving millions of people of this beautiful science specimen. Specimen? Yeah. Lost for words. All right, Iago, tell me about yourself. So where are you from exactly?
I'm from Buenos Aires.
Heard of it? That's in Argentina, yeah?
Yeah, capital city of Argentina.
All right, so how did you get interested in science? When did you first know that science was the thing for you?
Wow, that's a tricky one, because I've been into science since my childhood.
Were you born this way?
Yeah, it's like it's actually in my genes.
Do you have any other scientists in your family?
No, both my parents are doctors, medical doctors.
So yeah.
No,
So that doesn't count.
That doesn't
They're
count.
not
That doesn't count.
scientists.
They're not scientists.
They just save lives. Whatever.
They save lives. Right.
That's like such a sciencey thing.
We're
to say.
curing cancer.
You're like,
Curing
no,
cancer,
no
yeah.
scientists, just like doctors.
Okay. So yeah,
Whatever.
that's basically it. I had a lot of books in my home back in Argentina. So I had books from dinosaurs and planets and.
So when did you first get in? So you're an astrophysicist. When did you first found yourself drawn to astronomy and to the outer world rather than biology or medicine?
Yeah, actually, when I was in high school, I had this astronomy group. I was that nerd. Yeah, I used to skip classes to go to the astronomy group. Yeah.
Yeah, there's a lot of nodding heads in the audience.
Yeah.
Like, yep, that was me.
This is actually a support group.
Yeah.
We
Hello,
meet every
my
Monday.
name is Iago. I'm addicted to science. Yeah.
You're safe with us, buddy.
Yeah. I know. That's why I came. So yeah, that's basically it. Yeah. I'm interested in all kinds of sciences, but specifically for physics and astrophysics, I don't know. I did. Thank you. Specifically for physics and astrophysics, I don't know when I made the explicit decision to
But you
follow
were,
this
I mean,
path.
that's pretty young to be. So you said that in high school you were part of the astronomy club.
Yeah.
Yeah, we talked about this a little bit before the show. My question for him was, did you guys just get high and look at stars? Because that's what I would have done in high school.
Which, granted, that's what Hannah did in high school.
Yeah.
But it
And
was
I
Star
wasn't even-
magazine.
No, it was real stars, but I wasn't in an astronomy club.
Brad Pitt doesn't count. So you then went on and you did a bachelor's. Were you focused in astronomy then, or you covered all the?
No, my bachelor degree
fields.
covered all physics.
Mm-hmm. And then you went and you did a master's.
Well, actually, back in Argentina, we have the licenciatura. It's like licentiate. It's equivalent to the master's degree here. So it's both bachelor and master.
It sounds like a beautiful way to say master's.
Yeah.
It's true. So one of the things I like to talk about. No, it's all right. Pretend like it didn't happen.
Okay.
So, do you find being a scientist? Do you find it frustrating, or day to day? Are you miserable, suicidal, questioning your self-worth?
Well, there's quite a lot of frustration during my career. It's it took me quite long to get a degree.
You're in a safe space. Tell us about it.
Yeah. Well, that's why I came here
Yeah.
again. It took me 10 years to get my degree because I was doing other stuff also, but I had to learn to deal with the frustration.
What do you find most frustrating?
Well, things are not going on well. You can't solve things. You get stuck for hours or weeks with just one mathematical problem, and that I think that most of us felt that. Yeah.
Yeah, totally. Wait, did you go to UBA? Did you go to University of
Yeah,
Buenos
to the
Aires?
University of Buenos Aires. Yeah.
Everyone there spends 10 years getting
Yeah,
a degree.
it's really
Because
hard.
it's free.
Yeah, but it's free. Yeah, right. It's
So you
free.
go and then you're like, man, I'm going to take some time off, or I'm going to
Yeah.
fail all my classes this semester, but it doesn't matter.
Yeah.
Is that a luxury, guys? Everyone should move to Argentina.
Yeah.
Sounds like a terrific educational system. Oh, everybody fails.
Well, it's like when you
Isn't that-
graduate, it means that you like struggled, like you went through.
Yeah.
This is what people say. It's like if you graduate from UBA, like you
You
went
know how
through.
to fight.
You went, yeah, you know, yeah, you've like street smarts. That's what people told me.
Yeah.
In
So
Buenos
you
Aires.
really know-
That's the big thing about you. I don't know. You learn how to struggle, how to deal with frustration, and
Mein Kampf.
yeah, that's it.
Bringing it back.
Kampf.
It is Jewish New Year, guys. Lashana Tova, everyone.
I was going to say it's German for my struggle, but all right, let's move along. So, what time of day do you find that you're happiest? What part of your day to day, as a researcher, are you happiest?
I'm a night person, so yeah.
Yeah, you
not
are.
in that sense, not in that sense. Yeah.
Oh,
Yeah. I'm
Just look at him, guys. Come on.
okay. Yeah. No.
Calm down.
I feel like I wake up at 9 p.m. My brain does wake
yeah.
up at 9 p.m. It's like.
So do you work in a lab?
No, actually,
No.
most of my work is theoretical.
Okay.
That's my sex life. So.
Preach.
Science making jokes.
Yeah. No, yeah. I did some lab work back when I was in the career, studying. But now my work is mostly theoretical, so yeah.
So you can get up at 9 and just
Yeah,
do your
yeah.
work then, like you don't have to.
I only need a laptop and access to the mainframe computers, so that's it.
Cool.
I can go to work whenever I want.
God bless computers. So how about you tell us a little bit about your work then? So it's about binary stars and neutron stars specifically, yeah?
Yeah. We're gonna talk about space now.
Yeah.
Space.
Yeah, no,
oh wait,
so-
can we see how many physicists do we have in the audience?
That
Okay.
for our listeners at home, that's roughly 2,340 people.
Yeah. Okay, and how many people are not scientists at all that are here right now? Okay, a lot of you guys.
Not
Okay,
that-
so
We're a
so-
majority, so
Yeah, so
First time.
just saying, explain. Know that there are a couple of physicists that are going to know what you're talking about, but
what about people
just
from
just
all
saying
fields?
for a friend, like some people might not know what's going on. So
People
just
from
for a
all
friend.
fields, not physicists. How many people from all fields?
From other scientists,
And scientists,
other kinds of science.
biologists.
Biology, where are you at? Yeah,
Yeah.
those are the sexy people. Not that I'm
Cool.
biased.
Cool. Okay, so tell
So
us
yeah,
about your work. Tell us about your work.
Maybe at first I try the short sentence with the big words and then explain the big words.
Yep.
Yeah.
Do it.
Great plan.
Well, my thesis project is about modeling radiation-driven winds and X-ray bursters.
Whoa, what? Did you say that again?
Louder and slower.
Yeah, louder and slower. Modeling of radiation-driven winds and X-ray bursters.
An X-ray what?
X-ray bursters.
Bursts.
It's burst.
Bursts.
Burst,
Okay.
but a burster is
Bursts.
the thing that makes bursts.
Yeah.
Yeah.
Okay. X-ray. Okay. Cool.
So yeah, I'm gonna explain
Yes.
all of that.
Explain
yeah.
now.
So X-ray bursters are systems of binary stars. We're talking
Okay.
about binary stars.
Binary stars. Okay.
That's
know-
2 stars.
2 stars. You know,
I saw you, non-scientist.
Dos.
Two
Dos
stars.
estrellas.
you know.
At the bar, you'd be
and-
like, binary star over here.
yeah.
Dos
Sorry.
estrellas? Sorry. keep going.
Okay.
I'm
So
here.
binary stars, when 2 stars come closer and they start, hey, do the gravitational dance and
Yeah.
let's exchange some fluids.
Whoa. Buy me dinner first. Come on.
Okay, so yeah, that's what's going on actually, right? Two
I'm right
gravitation-
here.
What?
Tell me.
Flirt with Matt. Here.
All right, so you have 2 stars.
You
yeah?
know, this binary stuff, the bi in it's not what you think.
Yago's killing it tonight, guys. Come on.
So yeah, basically it's these types of binary stars where one of them is a compact object. It's like a very dense material in it, like a neutron star or a black hole or a white dwarf. Do you guys have ever heard of that kind of stuff? No.
Yeah. What did you say? Neutron star, black hole, white dwarf.
Well,
Let's get some definitions over here, Yago.
okay. So, maybe I'll explain later what a black hole or a neutron star and a white dwarf is. The thing is, in these binary stars, one of them is very dense, so it has a very strong gravitational pull, and strips from the other star, the material in it, mostly hydrogen and helium. And then the material starts falling in and forms a disk. It's called accretion disk. And then,
Like on Saturn.
But bigger and more energetic. Yeah.
Okay, cool.
So the material in the disk finally falls into the object, the neutron star, for example, and starts generating this very energetic nuclear explosions, right?
Okay.
And these nuclear explosions emit very strong X-ray radiation, and that's what we get from the telescopes and observatories in orbit, because X-ray emission does not come through the atmosphere. So,
Right. So just correct me if I'm wrong, but neutron stars are the really dense stars that spin really quickly, and they're projecting these X-ray bursts, but like rapidly, as if it were like a lighthouse spinning super quickly. Yeah.
Yeah, we're talking about it's actually called pulsars.
Pulsars. Oh,
yeah, pulsars.
That's different than the neutron star.
Yeah, pulsars are actually neutron stars that are also accreting material, but they have strong magnetic field.
I see.
Yeah, and the magnetic field ionizes the material in falling, and the thing with charged particles in the ionized gas is that they follow the magnetic field and fall into the poles of the neutron star, and as it rotates very rapidly, the infalling material emits radiation, not only in X-ray but also in all spectrum.
Yeah, energy.
Yeah, and the radiation comes in the axis of the magnetic field. So if you're not in the way of the radiation, you don't see it. That's why they call pulsars, because it's like a lighthouse effect. You know?
Exactly.
Yeah.
Okay. So you're trying to model, let's say maybe the chemical consequences.
Notice
of
that
this.
I'm talking to you right now.
Yeah. Tell me more.
Let's talk about science.
I want to talk about science too.
Are you a scientist?
No.
I'm a total dick right now.
But I'm interested. I'm interested. No, this is cool. I'm okay. I'm learning.
Okay. So I talked to her.
That's fine.
So yeah. What were we saying? Oh, sorry, I forgot.
No, okay. So yeah, so you're trying to I don't know what you're doing.
So yeah. Neutron stars steal material from the companion, they form a disk, and then the material falls and
explodes.
And yeah, when it's
that's fun.
highly compressed, the nuclear reaction starts, and we have this explosion, very energetic explosion, that is almost. It is among the most energetic events in the universe. It's like.
And so we can see that.
We can detect.
Because it's like X-rays.
Yeah, we can detect the X-ray radiation from telescopes in orbit.
Cool. And so what does this do? Why are we? Why
am I studying this?
Yeah.
Well, the other part, I said radiation-driven winds and X-ray bursters. Okay.
Radiation. Okay.
So yeah, the material that is falling inside on the surface of the neutron star forms like a new layer of new material that is not composed of neutrons. You know, neutron stars are mostly composed in its inner layers of neutrons. Just
neutrons, which are
very dense, compacted. Imagine like if you have the mass of the sun. You know, the sun.
Compacted. I know the sun.
Yeah, you know the sun. You know that
I've heard of it.
yeah.
Not that dumb. Come on, guys.
It's that big red thing in the sky.
Yeah.
It's red.
Well, imagine if you have the mass of the sun and you can compress it to a radius of 10 kilometers. That's it. 10 kilometers.
And made of neutrons.
To the side of the sun. Yeah.
Which have no charge, if I'm right. Okay.
Have no charge, yeah. But there's also some other outer layers in the neutron star that are not composed of neutrons, composed of regular atoms.
Okay.
That is taken from the material in falling, right? And these outer layers generate these nuclear explosions, and the radiation generated in those explosions can, well, actually that's what I want to see through my model. It can or cannot, maybe not, maybe yes, drive away the outer layers, the atmosphere of the neutron star, the corona, it's called, right? And maybe in that wind outgoing, may also seed the outer space with the ashes of those nuclear explosions. The ashes of those nuclear explosions. Let me take you a little bit back.
Yeah. Okay.
And this nuclear explosions, this process called fusion, right?
Yeah.
You know, nuclear explosions can be from fusion or from fission.
Okay.
Right?
Yeah.
What we
I
have
remember
now
that.
in our nuclear reactors is fission, which
Atoms going apart.
is
Yes.
splitting heavier atoms. Fusion is the other process. It's
opposite.
taking lighter atoms, lighter elements, and fusing them together, smashing them together
Yes,
to
yes,
form
yes.
heavier atoms.
Remembering this
Right.
from like high school science.
Yeah. Periodic table.
Yeah.
You have
did
that
that.
in your wallet right now?
I, in
He
fact,
probably
do.
does.
Yeah.
Nerd.
Yeah, I remember because the
I was-
first time.
oh, okay, yeah. I really carry a periodic table with me.
Yeah.
You never know, you know? You never know when you're going to need to prove.
Just
Bar
to certify
trivia.
you're a scientist.
Yeah.
It always comes in handy at bar trivia.
And I'm sure it really helps you.
How many
get
girls
laid.
did you pick up with a periodic table?
What's that?
How many girls did you pick up with a periodic
Yeah.
table?
I can tell you how many I sent away. Way more than I can count.
Yeah.
All right, so it is sad.
Oh,
right.
Oh,
yes.
thank you.
So
This is going to make me so much better at science.
This is free, right?
yes.
I'm not paying for it.
Drink up, professor.
So
Drink up.
if I can like
Cheers.
recap then, the idea is that you have a binary star
Yeah.
system, right? You have two stars, and one of them is a neutron star,
Yeah.
super dense, and so that dense mother. I'm trying not to curse as much.
Mother Earth.
It's a fucker.
It's
It's
hard,
stealing.
it's hard.
It's stealing material from the second
Yeah.
star, yeah. And as that material crashes into the accretion disk,
Yeah.
it's so energetic it creates these fusion events that you believe are creating some of the heavier elements in the periodic table.
Yeah, that's right.
And that's
And-
that's what you're trying to model, right?
Yeah. I'm trying to model if the radiation generated in those nuclear explosions is enough to push outwards the outer layers and seed the outer space with heavier elements. Because, you know, we currently don't know how did we get in this universe with those elements of the periodic table with the current abundances, you know? Some of them we can account for in, I don't know, for example, supernovas. Supernovas generate these nuclear explosions strong enough to generate heavier elements, but the numbers don't match, you know? The amounts of every heavy element don't match with the ones we observe. So we're trying to come up with some other explanation as how did the heavy elements come with the current abundances.
When you're
in the
saying
universe.
heavier elements, which ones are you talking about?
All of them.
I can show you.
How heavy?
All
Yeah.
of
Let's,
them.
okay. See, this
Yeah.
is when it comes in handy having a periodic table. No, because I thought a lot of those elements were like they're not naturally found. And you have to create them.
The-
Is this tubby motherfucker right here?
Let me
Yeah.
see. Starting from what number?
Oh, that's tiny.
Well, yeah.
Starting-
So the sun, for instance, that features fusion reactions.
Yeah.
But it's hydrogen into helium, yeah.
Yeah, the sun fuses hydrogen into helium. Then we have other types of stars which are more evolved. Then start fusing helium into, I don't know, oxygen and carbon, and then to iron.
Do you have an idea of like which elements are not accounted for in our current? Understanding the
If
world?
you are asking me numbers,
No, you don't.
Yeah, which ones of these?
Point
are you
to the one that hurt
confused
you.
about?
do you
It's
see
like,
this?
what-
I mean,
I don't know. You know how heavy
They-
is,
look,
is
they have it
too heavy?
memorized.
Like I don't know. This is I'm curious. What's like what constitutes a heavy element? I don't know.
well,
Anna,
actually,
it's
Is
okay. It's not
mercury a
you.
heavy
It's don't
element?
worry.
That's
I don't
a
want to
good
give the
question.
periodic
You're
table,
not a
like,
heavy
wait.
element. You're
okay,
beautiful.
Thank you guys. Aw.
Oh.
Isn't he sweet? Isn't he
Yeah.
sweet?
Well, actually, if you're talking about the fusion or fission, you know,
Yeah.
naturally heavy elements do disintegrate. Some of them do disintegrate into lighter elements,
Right.
and they release energy in the process.
That's radioactive decay.
Periodic
Yes.
decay, yeah.
I know about that.
But lighter elements can be fused and also release some energy.
Uh-huh.
But that is up to iron 60 also.
Okay.
So if you need to fuse a heavier element, heavier than iron 60, you have to put in some energy. So those kind of reactions can only be can only take part in very cataclysmic, energetic, violent events like supernovas or
Yeah.
X-ray
Or
bursts.
like a neutron star
Like neutron stars. Yeah.
exploding things.
So that's why they're not easily found in the universe. The universe is mostly made of hydrogen and helium and some of lighter elements, but not the heavier ones. So how can we account of the existence in the current abundances of the other heavier elements? The fact is, we have to figure out which mechanisms can create them. Supernovas are one of them. Neutron stars are the other, but the thing is that the neutron star has an extreme gravitational pull, and it's not easy to get out of there.
Right. This was one of the facets of your research that confused me, because so basically what you're trying to model is, or the idea is that as this material from the second star falls into the neutron star, it becomes heated, activated, fuses, and then explodes and is sent out again. Yeah, but you have to or the thing that confuses me is that you have a process where you're sucking in material and then blowing it out again. How? Get your mind out of the gutter. How do these happen simultaneously, or how could they?
The thing is, the material falls constantly. The material falls constantly to the neutron star, and when it reaches a certain density and pressure, it generates this nuclear reactions. The nuclear reactions are violent and are periodic. Actually, they happen very often. And when this nuclear reaction happens, it can blow out. Maybe not. That's what I'm trying to find out. It can blow out the outer layers with the ashes. Basically, the neutron star is eating material and then farting.
Yeah. Oh, okay. Yeah.
And
I was gonna say, is a neutron star?
Yeah, they're farting
bulimic?
in X-ray, and I wish to know if with the fart comes something else.
Yeah.
A very special fart.
No.
Yeah.
So, talk to me a little bit about how you build these models. So, even as a researcher, when I hear model, I'm thinking like paper mache volcanoes, right? With like baking soda.
It's a theoretical model, of course.
Which is a fancy way of saying.
Yeah, I have to.
It's math, yeah.
Doodle some equations, some differential equations.
Okay.
Put in some general relativity, quantum mechanics, and quantum effects that transmit energy from radiation to material.
But how does that work in like in a general sense? You build so you make some formulas, right, that are supposed to mimic the way these neutron stars are bringing in energy and then releasing it.
Yeah.
And then what do you test that against? Like I can write.
Well, actually, the first step is coming up with the equations.
Okay.
And that's what I should be doing like this month. I don't know if my thesis director is here, so no.
This counts towards it. So when you go to, are you like
just I'm way ahead.
Yeah. What's your? I mean, like, do you have like a list of your favorite equations and you just mash them together, or?
Well, the thing is, this has been done before, but with simplistic models. You know, spherical symmetry and without general relativity and so on and so on. Because the thing is, back in that time, the 80s and the 90s, they didn't have this computational power we have now. So basically, I'm going to try to write some more complex equations that include some more realistic situation, and then try to solve them. But trying to solve them, it's not easy because these equations may be so complex that you cannot solve them analytically. You have to use computers to solve them numerically.
Do you use supercomputers?
Well, yeah. I'm hoping I have access to the mainframe of the BSS.
Barcelona Supercomputing Center, BSC.
BSC, yeah, Barcelona Supercomputing, yeah.
I know about these things.
Atta girl.
Also, another thing I'm gonna try. I don't know if I should say this because it's top secret.
Ooh.
I'm gonna try and use parallel programming for trying to solve this. Woo! Yeah, thank you.
Parlay programming.
Parallel programming.
Parallel programming.
Yeah, because most computers nowadays have CPU, you know, the central processing units. They come with nowadays like 4 or 8 cores. I don't know.
Sure.
And the thing with these cores that they are super powerful, but they're just 8, right?
Yeah.
And you have to connect several computers in order to do parallel programming. to divide the calculations among all the processing units. But the thing is, there's this new thing called parallel programming that uses GPUs. GPUs are graphical processor units, the same you use for computer games.
Yeah,
I
which
take
is
so
like
much.
it's like that's a. I mean, it's a little. That topic is clearly not exactly not your research, but why I have noticed though that as when you go to buy a computer now, the graphical processor is now it's seemingly more important than the actual CPU.
Well,
Is that
yeah?
so? Are you going to just have like a super gaming computer?
Yeah. For my
It could be.
I don't know if I'm gonna try to solve the equations or place. I don't know. Okay. Yeah. So the basic thing is that graphical processors have a lot more of single unit processing units that are cheaper, are simpler, but there's like 1,000 of them.
Yeah.
Right.
But this sounds like a technical problem.
Yeah.
That you're. So you have one issue, which is to actually derive and write the formulas, and then you're trying to compute what, I don't know, maybe the constants are in your formulas, yeah?
Yeah.
And for that, you need to use the computers. But in order to do that, you want to take advantage of these new graphical processing units.
Yeah.
And so you have to think of a new way to program for those. Is that?
Well, actually, that new way of programming, it's not that new. It's relatively new, and it's been applied to many fields in physics. But currently, I didn't see anything in astrophysics. Actually, in astrophysics, we're still programming in Fortran, which is ancient.
Do we have any computer programmers in the
I'm
audience?
From the 80s. Yeah. And Fortran, maybe C programming language, but not so much in Python. And Python and C have these libraries implemented that help you run some processes in the GPU, in the graphic processor unit.
So you have to pick the language that works best for you.
Yeah.
Okay.
Yeah.
So now I want to get back to. So you have this model, though. What are you going to test the model against?
Well, actually, when I'm finishing the model and run the simulations, they take like months of processing.
Sure.
When I get the results, I have to compare them to the observational data. The observational data comes from X-ray observatories currently in orbit. So yeah, I have to compare the data with the results with the data and see if the model is good. And well, actually, that one thing we're hoping to see if this model helps rule out some other theoretical models about the equation of states of neutron star. The equation of states basically relates the radius of the neutron star with its mass. So currently we don't have a way of determining the radius and the mass separately.
It's not just a giant orange full of neutrinos.
Yeah, neutrons.
Neutrons, yeah, sorry.
Neutrinos are some different.
Totally different.
Big difference.
Totally different
Yeah.
thing, Matt. Come on.
But
This is actually a question that I wrote down. So are neutron stars really made of neutrons? And then is a fig neutron just fruit and cake?
Fig Newton.
Ah, that's my mistake.
Fig
But
Newtons. Delicious.
Trying hard. All right, but one question I like to ask, though, is that imagine, if you will, you could suspend the laws of nature, yeah? And you can go plop yourself down right next to this neutron star
Oh, I
to
wish I
study
could.
it. What would you, I mean, like, what would you actually look for then if you could just, if it was, say, you know, on the other side of town? What would you look for? What would you bring with you? You know, what would be the things you would want to know first?
About neutron stars.
Yeah.
Well, actually, that was I was going to say before. There are several models of the actual neutron material inside the neutron star that they're all theoretical, and we don't have a way to decide which one is correct. So, I don't know. Your question is, what would I take if I could go to a neutron star and?
Well, it sounds
measure-
like what you would want to know first off is, yeah, what is actually inside this delicious fruit and cake star?
Well, actually, that's very interesting because
Yeah.
this is all theoretical, right? But because the inner parts, the inner layers of the neutron star are made mostly of condensed material made all of neutrons. It's just like one big atomic nucleus, but just made of neutrons, no protons. Maybe there are some protons over there, but it's quite complicated and quite difficult to imagine. You know, it's like And actually, the theoretical physicists come up with some models and some funny names. You know how physicists like funny names like
Quark,
quark and
Higgs boson.
up, down, bottom, strange charm, and those, and flavor and yeah. How do
You have a
quarks
favorite
flavor?
weird name?
And color. Yeah.
Oh, if you discovered some sort of element or particle, what would you name it?
Oh, that's a tricky one. Well, I think
Iago Herrera.
Yeah, the YH particle. Yeah. Ego particle.
Iago William.
I don't know.
Yagarium.
I don't know. So, yeah. Well, actually, the funny names I was talking about is like because the way that the neutrons organize in these layers, they all have names of pasta dishes. You know, pasta dishes. Like spaghetti and gnocchi.
Oh, pasta.
Really?
Lasagna.
Pasta
yeah.
dishes.
Yeah.
Whoa. Is there a gnocchi?
I believe so. Yeah. I don't remember quite exactly, but yeah, there's a gnocchi.
Love
Yeah.
gnocchi.
Yeah, because they arrange in stringy forms and they call it spaghetti. If they are arranged in layers, they call it lasagna. That's so funny. Yeah.
Makes sense.
Thank you, Italy.
Yeah. That makes me want to study physics now. If it's all pasta.
Just makes me hungry.
I want to eat a neutron star. That's
Just
maybe
eat it.
not a good idea. Yeah.
Great.
All right. So now's the time where we're going to open questions up to the audience. If anybody has a question, just come up here and Hannah will give you a microphone.
Really?
Yeah. Anyone have
Anybody?
questions?
I thought you were going to ask me some
Oh,
personal
I know.
questions.
Fergus has a question.
Yeah.
You might remember Fergus from episode 2 of Comics Curing Cancer. He's a space scientist.
Whoa.
Yeah, so you mentioned that there's a discrepancy between the abundance of heavy elements that we see and then this prediction from maybe supernovae and so on.
Yeah.
I was just curious where we get the idea of where we get the measurement observationally from. Is it from locally from the Earth, or is there astronomical measurements? Because my concern would be the Earth is a very biased and special place that we're in.
Yeah. I know what you mean. That is actually not my area of expertise, but you have the measurements from Earth, but also from outer space. You have some certain elements emit radiation in some very specific spectrum, and you can measure that spectrum and have a spectroscopy. Thank you.
Yeah.
It's very difficult to speak in English with like 3 beers. You know?
Yeah. It's all right. It's hard for me.
Yeah. Spectroscopy, and yeah, you can calculate the abundances, maybe not only from near the Earth, but the whole galaxy. I don't know.
I'm
Okay,
curious,
cool.
though, if we can turn this question back on to Fergus, though. So, but no, are you suggesting, though, that, like, these heavy elements are only found, or exceptionally found here on Earth and the solar system? Or?
I think it's quite feasible that there could be a strong biasing effect. For example, if it was beneficial, here's a completely random idea. If it was very beneficial to have a highly radioactive planet because it then keeps the planet warm for long periods, then you can be habitable for a long period. That's a completely random idea, but you get the point. For these sorts of selection effects can mean that locally we can have a very biased sample of the worldwide, the universal distribution of materials. So you have to be very careful about what inferences you draw about what we see locally.
Yeah, that's right. But sorry,
Yeah. No, I agree. That if we have spectroscopic samples of heavy elements, I wasn't quite sure how high we could go up to. Or
also the spectrometry we can get from astronomical objects. It's just a very small part from the actual object, because you only see the radiation coming from the outer layers.
Exactly. Yeah.
You know,
So it must be really hard
What
to.
about the inner layers? The inner layers, the radiation gets caught in the mass.
But what is the what is the evidence? Spectral, right? Spectral. So, I mean, this is observable right now. Like, do we see evidence for heavy elements outside of our solar system or our galaxy?
Yeah. Actually, yeah.
So
But you'll have to extrapolate a little bit from that, because as you say, there'll be slightly biased observation. You won't see a perfect representation. Some will be locked away in the as you say, in the cores. Or
But for answering this kind of question, though, it's like a binary answer. If you see a heavy element outside of this this galaxy, then you know at least it exists there, and so it has
Oh,
to be
sure.
there. Okay.
Yeah, I'm just talking about
Yeah.
I'm not saying that it doesn't exist at all, but I would argue
Yeah,
the
I know
abs-
where you're going.
whether
actually.
there's a gap or not is interesting as to whether that's significant or. Yeah.
Indeed.
Yeah, but that's a very good question because, I mean, in science you have to make do with the data we have.
Absolutely.
No, we have to make new data to deal with what we have.
Yeah. Yeah. And
Or not. What? Go
that's why
fine.
Thanks,
Don't do
Fergus.
experiments. Thank you, Fergus. Any other questions from the audience? One
Anyone
more.
else?
Come on up.
up. Come on down.
Hello.
Hi, I'm Shenia. I have the typical question that all scientists hate, which is, what is a practical application of your research
Whoa, this is night
Besides-
talk.
besides-
That was on my sheet.
besides
I'm-
increasing the knowledge of astrophysics field?
Sorry, what?
Besides increasing the knowledge on your field.
Well, actually, this kind of works. It's like a test field for more theoretical questions, theoretical concepts. And actually, was this talk about the abundances of the elements. It's trying to explain the gaps we have in our models of cosmology. And yeah, thank you. But if you're asking me of a practical, down to earth application,
Yes.
well, it's giving me a job, so it's super important.
That's very a good enough reason.
I shall quote Richard Feynman. You know Richard Feynman, right? Well, Richard Feynman said physics is like sex.
Oh my.
It may have some practical application, but may have, but that's not the way we do it.
Good enough.
Thank you.
Amen.
That was a great
Amen.
question. All right, so just to close, we're going to play a real quick game because this is comics curing cancer. So very
Oh, I
serious
hate
now.
that game. Is that?
The game is called
Yeah.
Fuck, Marry, Kill.
Woo!
I hate that game.
So we have three popular figures in astrophysics. They've all written books you've probably heard of.
I hope I know them.
I'm sure you will. So you have to decide to fuck one, marry one, and kill the last. Yeah. Your choices are number one, Stephen Hawking,
Stephen Hawking.
known for his work in describing black holes and the resulting theoretical, I think it's still theoretical, effect of Hawking radiation. He wrote the book. They found that?
Sorry, what? They found everything.
So not so theoretical.
Hawking's radiation.
She's got some in her pocket. Sorry.
He can't help himself.
I
Really.
know, but I was like, because she's hot, but
Oh,
can't say that on stage.
I get it.
All right, so
I
Stephen
get it.
Hawking is known for the book Universe in a Nutshell. Yeah, I'm pretty sure.
And a
that's
lot
it.
of other things. He's known for
All right.
a lot of other things.
The second is Brian Greene, an American theoretical physicist and string theorist.
Sorry, who?
Brian Greene.
Brian
Yeah,
Greene.
Brian Greene.
He wrote The Elegant Universe. I've heard of that. I have
Alright.
nerd friends who read that book.
And the last
I don't
is
think I know him.
really.
No,
Oh well, you
I'm
can
not
kill
that
him then.
theoretical
We can
physicist.
Google him later.
That kind of theoretical physicist.
And then your last choice is Neil deGrasse Tyson.
Neil deGrasse.
Ow!
So
Apparently-
no women.
Nope.
No,
Which is gonna. All right.
no. I think
You have to
it'll
give me
even out the playing
at
field
at
for you,
least
man.
women.
Well, who is your favorite lady scientist? All right. Sorry, lady astrophysicist. No cheating.
Well, she's not actually an astrophysicist, but
Then she can't be your favorite.
well, I'm a physicist in general.
No, physicist. Yeah, go ahead.
Currently, I'm doing
right.
astrophysics,
Who's
but
your-
I don't know. Maybe Madame Curie. I don't know.
Of course.
Yeah, that's just a cop.
Classic.
Yeah, classic.
Anybody that's working right now that you really respect?
Women.
Yeah, women. if you want, that guy will tell you when the men's rights movement is meeting.
This is the problem, guys. Women, you should do science. Don't be like me.
Yeah. We welcome women in science.
Yeah.
Absolutely.
In physics, because
Ev-
biology does a lot of women.
All right, so
So we have
in this non-sexist edition of Fuck, Marry, Kill,
Yeah, who would you fuck? Who would you marry? Who would you kill? Let's
so
do
the
it.
options were
Stephen Hawking,
Stephen
Brian
Hawking.
Greene, Neil deGrasse.
Tyson.
oh,
Tyson.
that's difficult because I have to give you a reason for every choice, right?
Yeah.
Ideally, it's the end of the show. I mean, you could just
Okay. Who has more money? So I can say who marry.
Oh
Oh,
man.
who has more money?
You.
Probably-
Sugar baby.
Probably
Yeah,
Neil
but
deGrasse Tyson
Hawking,
is
probably Hawking.
loaded. I'm
I'm
sure.
sure.
I'm
Yeah.
sure Neil deGrasse Tyson is
Also,
loaded.
Hawking is paralytic, so if I have to fuck him, so
He's not
That
gonna run
doesn't
away.
work?
I don't know. All right. Let's.
I think,
This might not have been like the best.
yeah.
So
Imagine-
marry Stephen
wait,
Hawking. You can take care of him.
Wait, who played Stephen Hawking in the movie about him?
The red man.
Oh yeah, that's. So imagine instead of actual Stephen Hawking, imagine him.
So can we do time travel and get him?
Yeah, like-
before he.
You can have him whatever way you want, buddy.
Yeah, this is all imaginary. You're not actually gonna get to fuck, marry, or
the
kill
red
any
man,
of these people.
the red man portrays transvestite in
Yeah.
another movie, so
It was
yeah,
beautiful.
I could fuck that.
Yeah, yeah.
All right.
He did
Yeah.
that beautifully.
So
So-
fuck Stephen Hawking.
Okay, fuck Stephen Hawking. Boom.
Fergus has been saying that ever since Stephen Hawking went into his talk and gave him shit. All right.
So yeah, fuck Stephen
Real
Hawking.
true story.
Fuck that guy.
I shouldn't marry a stranger, so I don't.
So you're gonna marry
a
Neil
friend.
deGrasse Tyson, yeah?
Yeah, I'm gonna marry
Yeah.
Neil deGrasse Tyson and
Kill that
the,
string
kill the
theorist
stranger.
guy.
Yeah,
Poor Brian Green.
yeah. Poor Brian.
Fuck
Gaines.
string
I don't know what
theory,
he
y'all.
did, but I'm gonna kill him that way.
Cool. Okay, so fuck Stephen Hawking, marry Neil deGrasse Tyson, kill Brian Greene is Iago's final answer for fuck, marry, kill.
All right.
Yeah.
Thank you.
So that concludes tonight's episode of Cancer's Curing Comedy. There will be no more comedy, I promise you. No, comics curing cancer. So let's give a hand first off to DJ Charms. I want to thank my beautiful and talented co-host, Hannah Becker. And of course, our very special guest, Mr. Iago Herrera. Yeah! Come back next week, same time, same place. We'll cure some more cancer. Stick around. We're going to have some stand-up, the best comedians in Barcelona. They're going to perform tonight at Barcelona Comedy Kitchen. Stand-up. It's going to be a great time. It'll start in about 15 minutes. Thank you very much. Woo! Give us your email address.